for the cables, knowing that the tension is 1425 newtons in cable AB and 2130 newtons in cable AC, determine the magnitude and direction of the resultant of the forces exerted at A by the two cables. So what it means when you say exerted at A, it means that we are measuring our resultant from A, right? Measured from A. So the given are TAB is equal to 1425 newtons and tension at AC is 2130 newtons. Now, for this problem, it is advisable that we shift axis or we transfer the origin from point O to A. Now, why is it important? It's because we can easily see the possible direction and the current directions of our given forces. Now, if we say that we shift our axis from A, we can see that our tension AC is going down for our Y and going to our positive Z axis and positive X axis. And by the way, if we can notice, the axis orientation is not the typical axis orientation wherein the Z and the Y and the X axis are interchanged. But nevertheless, what is important is that we have to remember that when we are assigning our unit vectors, we always associate I with X, J with Y, and K with our Z axis, right? So there, I put our color blue. I rewrite the axis so that it will be much clearer in color blue, right? So yeah. Now for our BC, that's the TZ is going to the positive Z axis. However, our TY, if you can notice, it is going down, right? From point A to point C, right? Okay, so we can expect that our Y component for our AC would be negative, right? Okay. And if you can notice also for our AB, it is also going down. Now, by the way, one thing you have to remember is when you say we have to measure it from A, since we are talking about cable and the like, let's say cable, rope, string, all of these materials only exhibit tensile force. So if we are to measure the resultant from A, it means that our tension at AC and tension at AB as well is pointing away from point E, right? Because it is tension. Now, we have to, this is in terms of position vector, so for our resultant, the position vector of our AC, for our X, that is 900I minus 600J plus 920K. Okay, then we are to solve for the magnitude of our RAC, or basically the total distance from A to C. That is the square root of 900 squared plus negative 600 quantity squared plus 920 quantity squared. And then we input that in our calculator. So that's 900 quantity squared plus quantity squared plus 920 quantity squared. So that's 1420 millimeters. Okay, so that is the total distance from A to C. Okay, write it here. Now we can express our force or our tension in vector form. So that is T sub AC vector form is equal to 2130 newtons multiplied by our vector form of our AC over the magnitude. Then we copy 2130 multiplied by the quantity 900I minus 600J plus 920K all over 1420. And since we are dealing with whole numbers, we can immediately solve this one. So that's 2130 times 900 over 1420 gives us 1350I. Next, 2130 multiplied by negative 600 divided by 1420 gives us negative 900J. And lastly, 2130 multiplied by the fraction 920 divided by 1420 gives us 1380K, positive, of course. That is now the vector form of our AC. Now we move on to our AB. Now the position vector of AB is equal to, the x component will still be 900, right? Obviously, that's the length of CD. So that's 900I. Next, still the value for our y is negative 600J. For our z, that's going backwards, right, from point A, that's negative 360, and that's K. Okay, now we can now solve for the magnitude. That's equal to the square root of quantity 900 squared plus negative 600 squared quantity plus negative 360 quantity squared. Now we can input all of this in our calculator, and this gives us 900 squared plus 600 squared plus 360 squared gives us 1140. And now we can express our tension in its Cartesian vector form. That's tension AB, which is 1425 multiplied by position vector AB over the magnitude of AB. That's equal to 1425 times 900I minus 600J minus 360K all over 1140. Okay, now like I said, we are dealing with whole numbers. We can immediately solve this so that we will not have fractions in our writing our vector form. That's 1425 times 900 divided by 1140 gives us 1125I. Next, 1425 times negative 600 divided by 1140 gives us negative or minus 750J. And lastly, 1425 times negative 360 divided by 1140 gives us minus 450K. Now we have expressed our two tensions in its Cartesian vector form. We can now solve for the resultant. That is in its vector form as well. So the vector form of our resultant is equal to the vector form of tension AB plus the vector form of our tension AC, which gives us, for AB, that's 1125I minus 750J minus 450K. That's the entire tension AB plus 1350I minus 900J plus 1380K. That also is the entire tension AC. Next, we are to arrange like terms. That would give us 1125 plus 1350I plus negative 750 minus negative 750 minus 900J plus negative 450 plus 1380 quantity K. Then we simplify. 1125 plus 1350 gives us 2475I. So we just have to copy that. Then for our J, that's basically 750 plus 900, right? Negative 750 plus negative 900 gives us negative 1650. That's J. And then lastly, for our K, gives us negative 450 plus 1380 is equal to 930K. Now that is the Cartesian vector notation form of our resultant, showing the x, y, and z components of our resultant force. Now we can solve for the magnitude of our resultant. So we have our Pythagorean theorem, and we substitute that the square root of 2475 quantity squared plus negative 1650 quantity squared plus 930 quantity squared. Then we input everything in our calculator. Okay, there is some numerical discrepancy. So again, the square root of 2475 quantity squared plus negative 1650 quantity squared plus 930 quantity squared. Okay, so therefore the final answer for our resultant force, the magnitude rather of our resultant force, would be 3116.572,636,72772 newtons. Newtons, right? Newtons. Okay. Again, don't forget to box your final answers. Now, having calculated our magnitude of our resultant force, we can now solve for the coordinate direction angles. So we have alpha is equal to arc cosine 2475 divided by 3116.572,636,72772. Okay, so this will give us, but before that you have to input that in our calculator. So that's shift cosine or shift cos 2475 divided by 3116.572,636,72772 gives us 37.425,746,770.26 degrees. And don't forget to box your final answers. Next, for our beta, or the angle measured from the positive y-axis, that is negative 1650 divided by the magnitude of our resultant, which is 3116.572,636,72772, and we input that in our calculator. This gives us, so shift cosine negative 1650 3116.572,636,72772. And since we have a negative value for our y component of the resultant, we can expect actually that the angle would be greater than 90 degrees. So that's beta is equal to 121.96679751103 degrees. And lastly, for our gamma, which is the angle measured from the positive z-axis, that would be 900, the arc cosine of the fraction 930 divided by 3116.572,636,72772. Then we input in our calculator shift cosine, and this gives us around 72 degrees. Okay, 72.638,187,630.93 degrees. Okay, so this is an example using position vector wherein we shift our axis as well as the given labels for the axis is not the usual one. This is another example for three-dimensional analysis.